Good morning. Today we're going to talk about Chapter 12 presented by Sarah, Josh, and myself. And the title is Synthesis of the Plug Flow Diagram, Process Flow Diagram from the generic block flow diagram that we made probably about 2 months ago. And just to go over the outline, we're going to talk about the different sections like information needs and sources, the reactor section, separator section, feed preparation for both of those sections, major process control loops, and then finally a summary. And starting off with the information needs and sources, you have to talk with the other engineers and scientists before starting on a project, and this deals with different departments like marketing, where you have to talk to the customer, find out what their need is, and then design your process based on that. And you also have to consult with chemists and scientists on figuring out what the chemical pathways are and deciding which one to choose. And you also have to consider the cost of the reactants and see how that plays into the overall cost. And these are just three of the basic considerations to make before you start. And then the next step is to look at the reaction kinetics data. And you have to consider the temperature, pressure, and the composition, and find the kinetics reactions on all of those to actually make a well-diagrammed PFD. And another thing you have to consider is the physical property, and you can find a lot of the physical property for the materials to be used, but the one that's least available is the phase equilibrium, and you use that a lot when you do phase separation using separators and vaporizers and all those different equipment. And moving on to the reactor section, you have to consider the following fields. First one is the phase of the reaction. Is it going to be solid or liquid or gas? And if it is, then you have to consider vaporizers once again. And then you have to look at the temperature and pressure range it's going to be under, and if it needs to be heated up, you have to consider that as well. Also, if it's kinetically or equilibrium controlled, and if there's a solid catalyst involved in the reaction, if it's exothermic or endothermic, if that's the case, then you have to consider heat exchangers to try and make the process go by. And also look at the reaction selectivity, if it's a single pass conversion, and last stage was a gas phase oxidation. At times you actually have to have feeds outside the explosive limits, and that's where steam comes into play to heat something up without actually using steam to raise the temperature without keeping it safe. And moving on to the next section, it's a separator section, and there are actually two tables in your book, 12.1 and 12.2, and that lists all the different guidelines you have to follow. And most of them are just basically generic guidelines that you have to consider when you're starting a new project. And also, you got to look at the product, look at the specifications, see if it's heat sensitive, and if it is, then you have to make accommodations for that. And if it's hazardous, then you have to go by the different requirements by EPA and all those, and see if it's a HAZCON material too. And to talk about the next slide, I'd like to invite Josh.